Let's go ahead and look at our problem of the day. Read it along with me. Nora and a few people from her neighborhood are planting a community garden. Below are the designs for the garden. The community wants to fence the garden in. If they want to use the least amount of fencing, which garden design should they choose? Read the problem silently to yourself one more time. How do you know we're trying to find the perimeter of each shape? Say it to your screen. That's right. We were looking for the amount of fencing because we want to fence the garden in. So we want to find the amount of fencing that is needed, and fencing goes around the outside. We know that perimeter is the distance around the outside of a shape. So the fencing represents the perimeter. We don't have string like we did yesterday. So how could we find the perimeter? And how do you know that will work? Say it to your screen. That's right. We did some of this yesterday as well. We can add up all the side lengths because to find the perimeter, we need to combine all the side lengths and find the total distance around the outside. That's exactly right. So how could we represent the perimeter for design A? What equation could we use? Say it to your screen. That sounds like a great idea. So for design A, let's record our thinking. We have 4, 2, 2, 4, and 3 feet. We could represent that by using an addition equation and adding up all the sides. Let's start here. 4 feet plus 2 feet plus 2 feet plus 4 feet plus 3 feet. I put check marks so that I don't get lost in my math. All right, how could we solve this equation? Say it to your screen. That sounds like a great idea. We can use our facts that we know to make adding a little bit easier. We know what 4 plus 2 is and what 2 plus 4 is. And then we can add the 3. So we know that 4 plus 2 is 6 and 2 plus 4 is 6. So we can add 6 plus 3 to find our perimeter. 6 plus 6 is, say it out loud. That's right, 12. And 12 plus 3 is equal to, you got it, 15. We're measuring design A in feet, so we want to make sure that we record our unit of measure. So design A is 15 feet. Great work. Are we done? Say it to your screen. Not quite. We want to choose which garden design is going to use the least amount of fencing. So we also need to find the perimeter for design B. Let's look at design B. Now we know that the perimeter is the total distance around, and we can find each side length and add them to find the total. We also know that we can check off each side length so that we don't lose track. Let's try design B. We can add 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. I might want to count my sides to make sure I didn't lose track. Let's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's add them. 2 plus 2 is 4. 2 plus 2 is 4. And 2 plus 2 is 4. So now we have 4 plus 4 plus 4 plus 2. Let's add again. 4 plus 4 is 8. And 4 plus 2 is 6. 8 plus 6 is, say it to your screen. That's right, 14. What's our unit? You got it, feet. So, what is the perimeter of design A? Say it to your screen. 15 feet. What is the perimeter of design B? 14 feet. What was your big question? Say it out loud. That's right. If we want to use the least amount of fencing, which garden design should they use? Should they use design A or design B? Which perimeter is least? You got it. They should use design B because 14 feet is less than 15 feet. Sometimes, even if the shape itself looks smaller, check the perimeter before you make that guess. Let's think about which equation we used to represent perimeter. What did we do? Say it to your screen. That's right, we added. So we can say that we found the perimeter by adding together all the sides. Why does this work? Say it out loud. It works because perimeter is the total distance around the outside of an object. So your thinking question today is, when finding perimeter, we need to think, what is the length of all sides combined? Great math thinking today.